In this video, we are going to determine the height of the tree using a different method than we did by using the Pythagorean theorem and similar triangles. Calculation-wise, this method is a little faster and a little easier. We're going to determine what this angle down here is. We'll call it alpha. Because the Greeks discovered centuries ago that there was a relationship in the lengths of the sides, the ratios of those lengths, and the angles. And this deals with right triangles, so there's one 90-degree angle there. And those relationships were so important, they gave them names. The sine, the cosine, and the tangent. And those relationships were the side opposite the angle divided by the hypotenuse. The cosine was the side adjacent the angle over the hypotenuse, and the tangent was the opposite over the adjacent. Well, how would I remember all of that? Well, go soak a toe, huh? So toa. The S, C, and T for sine, cosine, and tangent. And then the OH, these are the ratio. It's going to be the middle letter over the second and third letter there. So O over the H, A over the H, and O over the A. That's the relationship. So if you can remember that, and who can forget SOHCAHTOA, huh? Write that down a couple of times and you'll have a hard time forgetting it. All right, so the next challenge then is, well, what side is hypotenuse, opposite, and adjacent? Well, in a right triangle, probably the easiest side to recognize is the hypotenuse, because it's always the longest side of a right triangle. The side opposite the angle that we're interested in, just start at the middle of that angle somewhere where it begins and just make a straight line until you run into a side. This is going to be the side opposite that angle. And the side right next to that angle is adjacent. So that's the adjacent. So that's the H, the O, and the A. Now, we want to know what the height of this tree is. So I need one of these functions. Well, we need to measure the angle. Sorry, getting ahead of myself. How do I measure this angle? Well, the cheapest way is to go down to the dime store and buy yourself a 6-inch protractor. I'm not a gifted artist. So it looks something like this. Mine had a nice little hole there. And they have degree marks along the outer edge here, and generally from 0 to 180 degrees. Mine had a hole in it. I tied a string to it, and then for a weight I used an old 1/2-inch drive socket I wasn't using, and that was my weight. The idea then is to get down on the ground right here at the top of the tree shadow. We measured this at 43.5 with our tape measure, and hold that protractor so that it's something like this, and you're sighting along this way, getting the top of that tree. The idea is that that string will dangle down here and cross at the degree mark that represents the angle here in degree measure. Let's say we did that, and this string crosses the protractor at 52.5 degrees. And we'll call that angle alpha. Okay, it doesn't matter what you call it. We now have an angle. We have a side adjacent, and we want to know the side opposite. Well, the one trig function that relates an angle and to the side opposite and side adjacent together is this tangent. So the tangent of 52.5 degrees then is equal to the side opposite that we want to know, that's our x, height of the tree, over our side adjacent, and we measured that to be 43.5. Alright, we're going to do just a tiny bit of algebra here and multiply both sides of this equation by this denominator, 43.5. And those cancel. So the height of our tree then is equal to 43.5 times the tangent of 52. So let's put that on our calculator. Make sure that the mode of your calculator, by the way, is set to degrees. Oftentimes the default, as is with this calculator, the default is actually radian. Radians are fine if you're using calculus and trigonometric functions, but when we're doing backyard trigonometry, we want it to be in degree mode. So make sure you set your calculator to degree mode. Okay, so let's do 43.5 times the tangent of 52.5. Enter. And it tells us that that is 56.9. Let's call that 57. Well, it's 56.7. Let's just round it up to 57 feet. And as you may recall from the previous video, that's how we calculated the height using similar triangles and the Pythagorean theorem. Well, we use the Pythagorean theorem for the hypotenuse. Okay, similar triangles figured that out. Alright, that gets us that. Let's find the hypotenuse. Well, since we already have measured accurately the 43.5 with our tape measure, let's use the cosine. So the cosine of 52.5 degrees is equal to our 43.5 divided by the hypotenuse. And the algebra of this has us multiply both sides by h. That cancels it here, puts it over here, then divide by the cosine. We get the same effect if we just swap these two in position. So h then is equal to 43.5 divided by the cosine 52.5. So 43.5 divided by the cosine of 52.5 is 71 and change. And I think we did with the Pythagorean theorem, we figured this was 71.5 or something like that. We rounded it up to 72. So this is approximately 72 feet. All right, there you have it. Next video, we're going to look at a completely different problem and add some more to our trigonometric toolbox.